I want to draw a couple pictures here, and I want you to tell me whether you can analyze these problems or not. Okay, the first one, we've got an object called object number 1 moving towards object number 2 that's at rest. So we'll say this guy is moving with a velocity of, I don't know, 10 meters per second, let's say. This guy has a velocity of 0 meters per second. And we'll say afterwards they stick together. Okay. Could you analyze that problem? I think you could. What would you do? How would you analyze that? Object number 1 moving towards object number 2, they hit each other, they stick together, they bounce off as one. We're going to say pi equals pf, right? We're going to say m1 v1i plus m2 v2i equals mvf. Agree? Not rocket science there, I don't think. Okay, this is what your quiz is on tomorrow. So if this doesn't make sense to you, what we've just talked about there, then make sure that you come and see me so that it does make sense, because this is what your quiz is on tomorrow. But this is not where I want to go with this here today, okay? I want to go a little bit further with this. Let's say now we've got object number 1 at rest, 0 meters per second. Object number 2 is moving this, say, downwards towards object number 1. It's moving with a velocity of, let's say, 10 meters per second. Downwards towards object number 1. They stick together when they collide. They bounce off, or they stick together. They head off as one object after the collision takes place. How would we analyze it? Well, the same way as we analyze this one, right? Pi equals pf. We'd say m1 v1i plus m2 v2i equals mvf. Agree? Again, not rocket science, I don't think. Question? No, that's a good question. No, that's a good question, though. No, it's not falling. It's just moving, say, southward. We're looking at it from above. In both cases, we're looking at it from above. Good question. All right. Now, we're not going to actually solve this because, in the end, we don't know what the masses are. Okay, if they're the same, then we could cancel them out. If they're not, then can't do anything with it. But what I can do is go one step further, even without knowing what the mass is. I can cross this term off right here. I can X it out. How come? Yep. Good. Its initial velocity is 0 meters per second. So whatever the mass is, it's whatever times 0 is 0. Good. What about the second one? The second problem over here. Anything I can cross off there? Same idea right there, except it's going to be object number 1 that disappears here because its initial velocity is 0. Does that make sense? Okay, nothing new here. We spent a few days talking about conservation of momentum, so why am I doing this again? Because now I want you to look at what would happen if I have object number 1 moving at 10 meters per second this way, and object number 2 moving at 10 meters per second this way at the same time. They hit each other at that point X. They bounce off as one object because they stick together, because Velcro or glue or something. Where are they going to go, by the way? If they bounce off as one object, where are they going to go? We don't know exactly, right? But we can make an educated guess. We can make not just an educated guess, a good, solid answer in terms of the general direction they're going to go. What is that general direction? Going to go off to the right like this? Oh, down and to the right? Yeah, they're going to go down and to the right somewhere. How do we know that? Well, we know that because if there's momentum to the right before the collision, there has to be momentum to the right after the collision by the law of conservation of momentum. If there's momentum to the south or downwards before, then there has to be momentum south or downwards after. So it's going to go to the right and downwards. Make sense? How would we analyze this? Notice what this problem is. This problem is just this problem and this problem combined. Right? If we take this problem and analyze it as two separate problems, then we can make this work. Let's say the x component, which is everything on the x-axis, and the y component, which is everything which is on the y-axis or up and down. Yeah. The x component would be analyzed by saying pi equals pf, m1 v1i plus M2 V2I equals MVF. We would cross off this term, even though object number 2 is moving. On the x-axis, it is not. Right, on the as far as the x-axis is concerned, it's not moving at all. It's moving only on the y-axis. What about the y component? We'd say PI equals PF. M1 V1I plus M2 V2I equals MVF. This time we cross off M1 V1I. Why? Well, because on the y-axis, the up and down, object number 1 isn't moving. So you're analyzing a problem involving 2 dimensions, not just x or not just y. We've got to break it up into x and y. And when we do that, we've got to look at one component or the other at a time. When you're analyzing x, pretend everything on y isn't there. You got to ignore everything on the y component. So look, hey, this guy's moving at 10 meters per second downward. I don't care. If I'm analyzing x, it's 0, because I'm ignoring everything y. If I'm analyzing the y component over here, then I'm ignoring this 10 meters per second. Why? Well, because I'm ignoring everything on the x-axis. So what does this problem become? It's this, right? It's this. Look, x component is exactly the same as this one. The y component is exactly the same as this one. You know how to do this, and you know how to do this. So you pretty much know how to do this. Now, we'd solve for VF here. There is one more thing here. We'd solve for VF for the x component. We'd solve for VF for the y component here. What do you think we'd do with it then? We don't want 2 final velocities. We want 1. So what are we going to do with it? What are we going to do with it, you brilliant physics 20 vector analysis people, you? We're going to add them together, Jacob, yes, except we're not going to say, 6 plus 4 is equal to 10. We're going to say x component plus y component is equal to whatever the hypotenuse is. In other words, we're going to use the Pythagorean theorem and the tan function to find the angle there. Does that make sense? Okay, we'll pick that up tomorrow, okay?